to Ndavika Academy. Today we want to look at integration, and we have been having a series of some special forms of integration. And if you find this kind of forms, you just follow the given procedure, and you are able to solve these questions without such a challenge. If you have not subscribed to this channel, kindly subscribe and let your friends know that we have the channel which is helping us improve in mathematics and get some concepts. Again, it is a discussion part. You can leave a comment down there as about any question or clarification that you want on any topic in mathematics. Remember, I deal with both pure mathematics and applied mathematics and statistics. So you can leave any form of mathematics there, and I will be glad to come back to you. So this is the Ndavika Academy, and we want to look at this particular form of integration. Having said so, we have this form here. The integration form or integral of 1 of x So if you have this form, the integration form, integration of 1 of x squared minus x squared, this is what you expect to get as the outcome or the solution to this kind of integral. That's the reason I'm calling them special for integration forms. So if you look at this here, you are going to get 1 over 2a, this particular a, square root of this one, and then ln of x minus a, so you are getting this one, the square root of this plus square root of this, and then we are getting x minus a over given x plus a. So you put addition, you send this one sign here, change to addition form plus a constant, of course. So let's look at an example here. So if I have this integral of 1 over this dx, and you can see this now, I'll take it like the whole of my x squared, and this one I took it like my whole of a squared. So remember, our concept should be able to make it look at the form that we want. So we are trying to manipulate this one so that it follows this kind of relationship. So what we're going to do here, we need to make the denominator appear as this, and therefore we arrange this. When we are doing arrangement for this one, you see n2 x squared here. So what I'm going to do here is to factor out x. So this one will be 2, and this one will be 2, because 2 times this one I'm getting 3 as in the form. So automatically I'm just manipulating the question so that it fits our form. So if you look at that, now from here I can see clearly I'm able to trace my x squared and my a squared. So this 3 over 2 is my a squared. So a squared in this case here is 3 by 2. So it means that our a now is actually the square root of 3 of 2. So wherever I want to have a, I'm substituting this with this, I'm putting this. So, that means applying the idea here, this will be true. This will be true because I have 1 over a half here, and coming out, I have a half from the general solution, and the half, the one that we have factorized from 2x squared. So I get a 4 here. So from what we know from rationalization, that's in science, we know that we can't leave our answer as in that form. So you have to rationalize your answer. So if you rationalize the answer, you are going to get this as the solution for our example. Remember, so far, if you have not understood any part of this, leave it like a comment. You have a question which is similar to this, but you are facing challenges, leave it also like a comment. I'll be able to look at it and reach you. Again, remember to subscribe, share with your classmates about this link, and let them be able to enjoy this kind of mathematics. Remember, mathematics is all the backbone of academics. Okay, we can look at another example here. So we have here this kind of integral here, and if you look at it clearly, you can see it can be fit the solution that you want. So our concept here is to rewrite this kind of equation here. We write this to our form that we want, so that we'll be able now to apply this special form. So what we are going to do here, we are going to introduce something that I introduced earlier in a previous tutorial about another form, and I'm trying to use this expansion here, and then we see what is happening. Okay, so when I square this, the expansion of this will be a squared x squared plus 2 x b plus b squared. Okay, so you can see I have a squared x squared plus 2axb plus b squared. If you look at this, the expansion of this one, and I try to compare with my equation here, you can see from here I can trace my hair, and clearly my hair is actually 2. If you are comparing this part here with this part here, okay, so again I can compare this part here, second part here, with this one here, and I can be able to trace that b here is negative, my b here is -1, because I have 2 and 2, because our hair is 2, so I have 4, right? So the negative sign here is coming from my b, so negative b. So that now if I have this, it will mean if I substitute here, this will be equivalent to 2x minus b, or this squared. So that if I square this, I'm actually going to get 4x squared, okay, minus 4x, okay, and minus, so it minus or plus 1. So if I compare this and this equation here, I think I can use another yeah. If I compare this and this here, I can see I'm lacking something here, so that this becomes -9. I'm lacking something here. I'm lacking to substitute to get 10 out of the equation, so that this equation now marries this one. Okay, so because that is true, that's true, we know that's true. Now it means It means now we can write the equation. So this equation here can be written, our equation down here can be written as 2x minus b, which is 1, remember, it's 1. Okay, so this should be 1, remember, squared minus 10. So that's our new equation here. So you can write this our integral here. We can write our integral now as we can write our integral now as integral of 2 over 2x minus 1, okay, 2x minus 1 to bracket squared minus 10. So remember this one like this, dx. So so that's our new equation, new integral. And now this our integral here now is now going to the form that we want. And because lifting our form, it means that if we can rearrange further, we can see that this can be the integral of 2 this. We get 2 out of this bracket here, it comes out like 4, okay, and we want 4 to capture the whole of this part here and this part here. So we'll have 2, okay, we'll have x now, then minus 1 over 2, because you have removed 2, because half times 2 we get 1, of course. Okay, so this one, this one is squared, okay, then minus, remember we are dealing with the whole of this 4 here coming, or the whole of that one. So we'll have now doubt if we do this as 5 over 2. I believe we can all see that. So if we rearrange that form, then automatically we have our a, and we have our x. We have our x. So if we have this way, we are going to see this one. We are going to see this one now. From our formula now, we are going to have 1 over 4, of course. 1 over 4, this is 1 over 4 here, and the 2, okay, and the 2, and we have this 2, that's half. So you can do this one and this, you can do this and this, you do this, okay, do this, get 2. So this one is half, it's no more, and we are multiplying this by now the half from the formula, half a, okay. Our a in this case is this one, but it's actually, this is a squared, so a square root of this is root of this. So half a root 2.5. You see now, if it's 2.5, and then you introduce the ring, and then we do plus, above minus, so it will be x minus square root of root 2.5 over square root of 2.5, and of course we add a constant. So this is coming to become 104 square root of 2.5 ln x minus square root 2.5 over x plus square root 2.5, something like that. And we have changed our format, our special form equation to that form. So this will become the solution for expecting solution for this question. You can try to look at more questions. If you have a question in either part of this, kindly leave a comment and subscribe and share. That's a key thing. Share and subscribe. Remember, this is Ndavika Academy. Okay. Thank you for your time. We meet next time, and kindly leave a comment for our discussion.